officially recording, says we're live. You're on, Barnabas.
Ready?
Thank you
Yeah,
so
it's
much.
going. It's going.
Thank you so much. Barnabas Akantambira, the country coordinator, ACLENet, that is Uganda. I want to take this opportunity to welcome you and thank you for joining us and to our first series of our webinars that we'll be having, teaching about lightning or talking about lightning. We are hosting and we are having a privilege to have our experts. For instance, today we have Ron Hall, who will be taking us over the teaching of today. So I want to thank you everyone for coming. And I also want to thank Godwin for having organized this. Thank you and all the staff that have tried your best to make this possible. Allow me to welcome Hall to start, introduce himself, and then he can take us through the session. You're welcome, Ron.
All right. There's my video. Let's turn it on for a short time here. Thank you for allowing me to speak to you. This is a very important topic to speak about the basics of lightning. And I have been involved in lightning for quite a few years. I'm on the board of, no, not board, executive council for ACLENet. So I'm quite familiar with the activities. I would ask if you can mute your microphones and turn off your videos. Some people having a little bit of shortage on bandwidth. So I'm a meteorologist. First, I've done thunderstorms and tornadoes and hurricanes and do lightning also. I'm having as a co-author here, Lila Zhang, who recently graduated at the University of Arizona. Here we're in Tucson, Arizona, where I live. And she is now at the University of North Dakota and very busy getting her new faculty position started up. She's at North Dakota. I am a one-person operation here in Tucson. And we both belong to the National Lightning Safety Council in the US, and we both are very active in ACLENet. All right, so let's have some fun here. How many of you have seen or heard lightning in the last year? Raise your hands. I can't see you, but that's okay. Raise your hands. I raised mine. How many of you have seen lightning or heard thunder in the last month? Think about it, last month. How many of you have seen lightning or heard thunder in the last week? In the last day? We had a thunderstorm here in Tucson, 3:30 in the morning. It woke me up, and of course I went out to the window and looked at it for a while, which is what I do. Anyway, virtually everyone in the world sees lightning sometime during the course of a year. I think 99.9% of the people do, not too frequently, and maybe not in the last month, but it is frequent. So lightning is all around the world. I've grabbed some pictures here. This is a picture from South Africa, one from Switzerland, one from Puerto Rico and the Caribbean. And these are pictures I took in the state of Oklahoma, Arizona, where I live now, and in Florida. The lightning phenomenon is the same everywhere, the same. So there is a network is owned and operated by Vaisala, where I worked for 21 years. And this is a global network. Billion lightning events every year. That's billion. So you see maximum in the US and in North and South America and in Congo and other parts of Africa and in the Southeast Asian islands and Northern Australia. So lightning is very common. So Godwin had this outline provided to me about a week ago, and I thought, well, that's directly, and I'll be talking about this formation of lightning, characteristics of lightning, how lightning comes to ground and chooses the target, which I think is very of interest to a lot of people. Lightning safe and unsafe areas, lightning in Uganda, and other basic information. The reason why I've included Dyla is that we put out this book last year about lightning in Arizona, in the state where we live. And Dr. Cooper and I published this book in 2018 about a general overview of lightning, more for the developing world. So that one is on the website, as I remember, of ACLENet. Lightning formation. Here's a picture from Cape Town. Look at what's going on. Here's the lightning start. This is a cloud to ground flash starting way up in the cloud, coming down, branching, branching, branching. And this one didn't make it, but this one did. It hit the ground. Here are some other ones. It's probably a time exposure of a part of a minute. I don't know. See all the branching coming down. Those are important. Here's another picture from a mountaintop in Switzerland. I've actually been to this place up in Mount San Salvatore in Lugano. And you can see all the downward leaders coming down, and only one of them had a successful connection on the ground. So lightning, all lightning has the cloud associated with it in temperatures colder than freezing at the top. Every time there's lightning, there's a mixture of graupel, ice crystals, and super cold liquid water. Now over here is graupel from a winter project that was published just recently. Those are pretty large graupel objects, but they can be sort of conical. But they're typically in thunderstorms, they're just kind of an irregular chunk of ice. And there has to be an updraft. So if you look at pictures, yeah, they're all displaced here. That's not right. Anyway, these should be further over. Anyway, there are updrafts in the clouds, and when it reaches the freezing level, which is probably right around here, all of that is a mixture of graupel, ice crystals, and super cool liquid water. Now, the details of that are, a lot of people are not quite sure. We agree on that. So let's watch a time lapse taken from here in Tucson. You can see the bubbles going up. These are called spherical vortices, or spherical bubbles. There they are all over the place. In Tucson here, the lower part of the atmosphere is dry. Now here it has probably reached the freezing level right around here. And I would expect that there was some lightning coming out of this. There was lightning's only a portion of a second, and these pictures are taken every couple of seconds. But anyway, this is a typical evolution of lightning over a period of time. Let me show it again. In the summertime, the mountains here are providing the uplift for the clouds to form. In places like Uganda, where there aren't too many mountains, this just happens because the heating of the day and the updrafts happen. So you see all these bubbles, and within these bubbles, once they reach the temperature colder than freezing, they're eligible to have lightning. They may or may not. So when lightning comes down from the sky and it looks for something to hit, comes down with these leaders. This is an incredible set of pictures from Brazil by Marcelo Saba and other people that know very well. And it's coming down in steps. We'll talk about that in a minute. It's coming down in steps. You saw in the other pictures, it's looking for something to hit. It's coming down, coming down. And we have never, ever seen this before, but this is the top of a building. You can just barely see here. And there are upward leaders coming up to meet the downward leader, and it connects and there's lightning. We knew this was happening, but there was never been a picture of this until years ago. So number 2 is the characteristics of lightning. 30,000 degrees Celsius, very hot. Intensity, an average of 25 1,000 amperes, 25 kiloamps. It ranges from 3 kiloamps to 300 kiloamps. 200 million volts, 2 centimeters in diameter. It's really small. The pictures make them look bigger, but that's not true. They're always this size, always. And the speed is 1/3 the speed of light, 100,000 kilometers per second. So it's very fast and very small, but very intense. So there are between 3 and 10 times as many in-cloud lightning events as there are cloud-to-grounds. Here's a picture from Florida that I took. Here's one from here in Arizona. Here's one, an anvil crawler that spreads out a long ways. So in-cloud events are very common. You need to pay attention to them for safety because they often will drop a cloud to ground along that path. So there probably was a cloud to ground or more back in here. There might even be a cloud to ground in here, but you only see the in-cloud part. So let's watch how this actually happens. How lightning comes to ground and chooses the target. That's the title of this section here. All right, this is from Tom Warner in South Dakota. Here it comes in all these branches, looking, comes down, hits the ground, and the light goes up. So here it's coming down. It looks like this one is the one that's fastest for whatever reason. One more time. All right, so I think I have another video from Tom. Yes. This is a frame rate of 5,600 frames per second. So this is not something you can see. And when we first saw these, we didn't know what a lot of this stuff is. These are cave something. Oop. So you can see over a period of a half a second, there's a whole lot happening. I'll stop this, just goes on and on. Let's watch this again. This first part here, actually, I don't remember where this ground contact path came from. Seems to be a core right up here, doesn't there? Yeah, that's where it's coming from. Oh, came from that one over there. This is just overexposing the camera. There's nothing you can do about that. All right, so anyway, that's what is really happening in the short time. One of the principles about cloud-to-ground lightning is that it flickers a lot. You've probably seen it flickering, sort of thing. So this is a picture I took from here in Tucson. This is a cloud-to-ground flash, and this is the first one. And then the return stroke is the second one here. Then there's the third one, maybe another one in between, 4, 5, 6, 7, 8, 9. This cloud-to-ground flash had 8 or 9 cloud-to-ground strokes, which follow the same channel. Occasionally, during the course of these coming down, one of them may lose track of where that channel is and may break off and go off to another place. It happens about 50% of the time. So let's go through this in some detail. The cloud-to-ground flash starts aloft in the charging layer between -10 and -20 Celsius. The flash starts toward the ground and step lead is about 50 meters. And once it hits the ground, light travels back up the channel. Yep, the charge is lowered, but the light goes up. The downward part is virtually invisible. And this whole process takes a tenth of a second or so. So when it gets close to within 50 meters of the ground, it looks for something tall, isolated, and or pointed. Tall is good. No, isolated or pointed. Isolated is good without tall or pointed. Pointed is good without tall or isolated. Or if there's nothing there, it just comes down and hits the ground or water. So the lowest tip of the lightning only reaches out 50 meters from the lowest end. So it's reaching out just a short distance because that's all it has is that last 50-meter step. So when it starts down the cloud, it certainly doesn't know if there's a hill a kilometer away or a water body someplace or a hill or an underground mine or a particular kind of tree. It has no idea what's going on. You see how fast it happens. It certainly has no idea what a person is carrying, wearing, or how that person is standing. None of those things are known to the flash. And if there's nothing tall, isolated, and pointed, it just hits open water like it does here, or a golf course here, spreads out tens of meters. So this flash was coming down somewhere right around here. I think it's a 50-meter stretch. So it was looking around 50 meters, nothing, hit the water because it had to come down. And if you're wondering, the current spreads out on the surface of the water. Can't see it in the picture very well, but it does it like this, and it doesn't kill the fish unless there's a fish right at that very spot on the surface. It doesn't penetrate the water. Okay, lightning safe and unsafe areas is the next one Godwin had developed. Is it safe to use a cell phone during a thunderstorm? Yes, if you're in a lightning safe place. The cell phone absolutely does not attract lightning. And rubber tires protect you from a direct strike to your car? No, but the car does. We'll talk about that later. Does metal attract lightning? No, but it's good at conducting lightning once it hits a metal object. Are tents and small shelters safe? Nope. Is it safe to stand under a tree during a thunderstorm? Never. And rubber soles shoes save you from lightning? No. Are passengers safe if lightning strikes a plane? Yes. So there's a number of us around the world that are working on lightning safety. There aren't that many. This is maybe a third of all the people in the world that are working on lightning safety. So here's Dr. Cooper. Here I am, Gopal Kumar from India, Shadima Gomes from South Africa, Mr. Guthrie from the US, and Sri Ram Sharma from Nepal. And we were all at the International Conference on Lightning Protection, ICLP, in South Africa 2 years ago this month. So lightning safe and unsafe areas. Two reliably safe places are inside a large, substantial, frequently occupied building. I'll show examples. Or inside a fully enclosed metal top vehicle, and I'll show examples. First, there are 5, or you call it 6, mechanisms by which lightning affects people. When we developed this, Dr. Cooper and I and Chris Andrews in Australia, some years ago, we had ground current quite large. We think it may be a little bit less than this, but lightning hits the ground and spreads out. Side flash is side flash, say, from a pole and comes over to a person. Contact is when you're holding on to something that is conducting the lightning's current, such as a phone line or a power line or something that's electrified in the house or building. Upward leaders are the ones that come from people underneath the thunderstorm, and we think this may be a larger component than when we did this. And the least likely one is the direct strike coming down and hitting you directly in the head. It hardly ever happens. Hardly ever. So light is so much concentrated on this and it's the wrong thing to concentrate on. And also blunt trauma, shrapnel falling out from a tree, or things falling on you or being blasted out. That's in addition. So lightning safe vehicles, fully enclosed, metal topped. I have a Camry, that's the exact model I have. That one's cleaner than mine. And it surrounds people with a Faraday cage-like effect. Faraday cage is one that says you're inside of a metal object and the current flows around it and does not come to you. So these are all good places to be. It may be scary and things might happen, but it's much, 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 much better than being outside. Unsafe vehicles are these. My wife and I went to Vietnam in 2019 and spoke to the weather. I spoke to the weather service there, and this is how the streets look. 9 lanes wide of scooters. There's another 9 lanes wide over there. Unbelievable. So a safe structure, we just use the word large, substantial building, one that's where people live or they work in. It's not a temporary hut of some sort. So these are a school, a house, and this is a hospital down the street from me. So these buildings have grounded wiring and plumbing and may have metal structural members. In the hospital here, when they built this about 10 years ago, it probably had metal studs inside. And there are strong building codes in the United States. You cannot inhabit a building unless it has passed the building codes. And the building codes have wiring, plumbing being grounded into the ground, connecting the wiring into a pole or a post that goes down into the ground. And plumbing also has the same thing. So you're safe inside. You have a Faraday cage around, and there's a path for lightning to follow to ground. There are places that are not safe. I took this picture in South Africa when we were at the lightning conference, and this one showed up recently, a very unfortunate case from Uganda, just a couple of months ago. These are thatch roofed houses, I assume, and here's the kitchen. And it had a thatched roof. You can see parts of it down here. It hit this building and unfortunately killed the woman who was inside preparing lunch for the people that lived in these thatched roof huts. Why it shows that one, that's lightning. So lightning protection, I'm not an expert in this, but the general approach is that there's a Franklin rod, lightning rod, a lightning arrestor, whatever you call it, a rod on top. It's connected to a long, thick cable that goes down into the ground, either in a stake going down into the ground or in a trench that's built. All lightning protection essentially consists of these 3 things. And there's a very, very sophisticated knowledge base on how this is done. So lightning safe and unsafe places in the United States, we have the National Lightning Safety Council. And John Chansenius is the head of it, and he collects the data on all the lightning deaths. And we have had 10 deaths so far this year. This one was just revealed to us in the media a couple days ago. So look at these numbers that we had in the United States. We had 49 or 47, 30, 40 in 2016. We had 11 in 2021, and we thought that was way low. We now only have 10. The number is just going down and down and down. And I spoke to some people from Canada 2 days ago, and the same thing is happening there. And it's actually happening in Mexico and in many other countries. It's a combination of education, which is what we're doing now, awareness, less people working outside in labor-intensive agriculture, better buildings, more vehicles, better medical care. All those things together really know how to prioritize which one's more important. So anyway, this is a common trend in developed countries. Okay, so let's talk about lightning in Uganda. First of all, here's a map of Africa with the lightning. 1.9 billion in 5 years, 39 million events per year. So you see this maximum that I showed earlier here in Eastern Congo. I don't have a real good idea of why this is happening, except it's very, very moist. And the thunderstorms occur here all year round. To the north, the storms only are in the northern hemisphere summer, and to the south are in the southern hemisphere summer. But here, apparently, there's 12 months a year. So there's a lot of interesting details in here. I've been looking at this for years. So let's look at the Uganda map. So there's 2 million strokes per year. You see there's a very strong maximum over Lake Victoria at night. At night. And I wrote a paper about this. That's meteorological factors involving sea breezes and lake breezes and nighttime drainage. So there's more lightning in the northwest and over the lake than other places. There's less here and less to the south, but that doesn't mean there's no danger. It still is dangerous because there's lightning. So you need to take it into serious consideration. And what happens is when there's not a lot of lightning, people tend to take more chances because they don't think it's going to happen. This is unfortunate. Now there is an interactive map here going down to the individual districts. Let's see if this works. This is something you can do at home. 360 data over the world. You can do this any place in the world you want to go. And there's that maximum over Lake Victoria. I like to use the color density scale here. Oh, that's the wrong one. I find it more interesting. Anyway, here's Uganda, and you can go down to the individual, to the area, and also you can actually go by district if you want to do it that way. So this is available to everyone, and I find it really quite amazing to do this for every place in the world. You can go to Australia and do it. I mean, they have really large states there. Anyway, so this is interactive lightning map, Visola.com. You just type in Visola GLD 360 interactive lightning map. Interactive lightning map, Visola GLD 360. So put that into the Google entry and you'll be able to see these. Okay, so those are all the main parts I wanted to talk about. Other basic information. Godwin, thank you for giving me an opening to put in some of my favorite figures. So here's Dyla, was actually at Mulabana School in Kalangala Island in Lake Victoria back in June. She's a member of the board of directors and had a little break before she started their new faculty position. So this school has 515 people, students and teachers. And Gopal Kumar, who was in that picture of lightning experts, he was on the left side. He provided a large amount of material at a very high cost to protect the school. Now, you're probably wondering how in the world lightning is detected. I've been around this since the very, very beginning of this. Here's a sensor for the U.S. National Lightning Detection Network, NLDN. This is in Yuma, the western part of our state, and this is Alto Andes over there. Much prettier here. And in Tucson, Arizona, here where I live, I went into an office with this display every day for 21 years, and they have moved this office now to Boulder, Colorado. I have my office right around the corner over here, so I could walk in here and look at the global map of lightning, that's that one, or the U.S. map of lightning anytime I wanted to. There are other things being monitored. So this facility was monitoring the health of the network, the health of the individual sensors, the communications, and hardware. So this actually was invented here in Tucson. That's why I live here. The National Light Detection Network was 40 years old June 1st last year. So detection has been around for a long, long time. So here's an example on the Weather Channel, which is a continuous 24-hour weather channel on cable here in the US, and it covers the United States virtually. That's all it does. So here's a storm approaching Chicago, which is where Marianne Cooper lives, right around through here, right there. So they have superposed lightning on top of the radar echoes. These lightning events come from the National Lightning Detection Network. In fact, every television station in the United States has access to lightning data and shows it when a big storm is coming. And they've been doing this for at least 10 or 15 years. Okay, so I have some more questions here. These are from various things in that. Last thing is wearing red attract lightning. No, that's apparently a Uganda thing. In a cloud, the gun flash, the current goes down, but the light goes up. Yes, that's what we went through. Can someone call lightning onto a person? No. Does covering a mirror keep lightning away? No. And are there 2 million lightning strokes a year in Uganda? Yes. So most likely, not everyone got these correct. Last couple of slides here. Arizona, where I live, is a mountainous, dry area with some beautiful scenery. And these are some pictures that are from our book of lightning. So there are people that go out and do lightning photography. I'm not talking about some people. I'm talking about 50 or 100 or 200 people in Arizona make part of their living photographing lightning in Arizona because it's so photogenic. We have mountains and we have clear air and we have high cloud bases and great sunsets and all that. So it's I went to a meeting that Lori Bailey ran it a couple of years ago, and there were about 150 people there, and they were shouting and screaming about beautiful pictures of lightning. So this is another way to look at lightning. And again, this book that Dr. Cooper and I developed is available, I believe, online on the ACLENet website. And that is the end. I have a little extra part here, but let's answer questions first. All right, Barnabas.
Yes, thank you, Ron. I think there must be a problem of internet everywhere now, I can see. But you guys, you can send in your questions as then Lon will help to answer. Or you can raise hand, then we connect to you direct and you ask audibly.
Isaac has a question. He's asked to unmute. Can you do that?
Not yet, no.
Yeah.
Okay.
I think what Barnabas said was that the internet is just so bad, as we have seen from Barnabas dropping on and coming back on again, that we just don't have the attendance that we expected. Maybe this is too early in the evening to have good internet. We'll have to see.
Well, being recorded, right?
Yeah.
So
Because we have already lost around 4 people whom I've been seeing, including Godwin, including Martin, including the guy we started with, Gilbert. All those guys are off now.
well, being recorded. Let me. I don't see any questions, so I have this what they call dessert. Okay. Okay, this is very loud and very, very flashy. If you are bothered by rapid light flashing, I suggest you turn away. This is 7 minutes that was developed by Dyla Zhang for her PhD. And these are photos and videos of lightning that she took here in Tucson from the roof of the Atmospheric Sciences building and put them together into a montage with a crazy, crazy soundtrack. So here we go. It'll start out quiet, but off it goes. This is Dyla. I've been up on this roof many, many, many times.
We're not hearing the music, Ron.
No, really. No, I don't think I can do it.
Maybe I can have Diala show me how to do it. And when I give my talk in about a month, we'll try it again with me and see if we can get the music.
Way too long.
No, this is the University of Arizona campus. Okay, anyway, the audio on that is off the wall. It's very, very good. The words are lightning and thunder almost the whole way. So as you looked at that video, you could see a lot of flickering. And those are the return strokes. In fact, most of the ones in that video are flickering. So those are return strokes of the cloud grounds. Anyway, that's all I have. And any other questions?
Thank you, Lon. You guys, do you have any question even about the video that you have seen?
I should comment that the reason why she took that video is that for her PhD, she was calibrating the US lightning network and the satellite lightning detection against ground truth. So you know from the video exactly when the lightning happened, and you go see what the network or the satellite did. So it took a lot of work to get that video, hundreds of hours. Okay, anything else?
Someone has a question, but I cannot hear. Gilbert, can you get clear network off
He
now?
just dropped off.
Oh,
Maybe we can ask people to submit questions and we can do that on the WhatsApp even
maybe.
as a continuation of our social media work and things like that.
Yeah, sure.
Okay, so if you can put that video back on with the sound, that would be great. It's pretty
Oh, we'll
good.
try. We'll
Yeah.
see what happens.
Okay. Okay, thank you. Maybe you can, after this, you can share with us what you've taught us, Lon, with the whole group, and maybe if it is also okay, you can share it on our WhatsApp group so that people who didn't attend, they can read through, and then after, we can also see through our YouTube channel, because this is recorded.
Yeah. The file's
Thank you.
pretty big, so I'll send it to somebody, whatever you want.
Okay.
Very good.
Thank you.
Outstanding. Thank you all.
Right. See you later.
Okay, thank you so much. Thank you all. Thank you, Lon, for today. I think it will be better if we have to do it next time. We do it a little bit late because it is terrible here in most likely in the all areas in the country. Because I'm in a different place, Martin is in a different place. Like Gilbert, I know he is also in Western Uganda, but you can see everywhere the network is on and off. Even Godwin himself, who is here in Kampala, also is off, and I spoke to him. His network is poor, so it's a general problem now.
Yeah.
Yeah, but thank you so much, Ron.
All right. Right. Bye.
Yeah.
Very good. We'll try it later next time.
Thank you.
Yeah.
Okay. Thank
Bye
you
then.
all for all your efforts